Welcome to Tomorrow's World Today, a show dedicated to the discovery of innovation and cutting-edge technology. We showcase the latest developments from the greatest companies and smartest people in the world. Tomorrow's ideas are out there. And through our journey of inspiration, we will create a plan for the park of the future. This is Inventionland World Headquarters. Here now is George Davison.
Hey, George, what are you doing in there? You taking a little work break?
Well, if it isn't tomorrow, robots, pay attention.
Hey, I know way better than to mess with the robot guards.
Actually, I'm glad you're here because I need to know how you feel about roller coasters.
I'm okay with the spinny spin, not so much with the up and down.
All right, well, I'm glad you're good with the spinning side because I'm gonna send you somewhere where you're gonna be going round and round.
Where's my next mission to?
Well, we're working on something new for the park. So I need you to go learn about the vulcanization process from our friends at Eastman. So you need to go to Akron, Ohio. That's the tire capital of America.
Akron, Ohio. Who knew? All right, I'm gonna go find my winter coat.
See ya. Let her go, robots.
I'm here today in Akron, Ohio, where I'm making some new friends. This is Charles Goodyear, otherwise known as the father of vulcanization, one of the key processes in manufacturing tires. The tire industry is constantly innovating, starting all the way back in 1844, when American chemist Goodyear and British inventor Thomas Hancock were both awarded patents for the vulcanization of rubber. To today, where companies like Eastman, which I'll be visiting, work at the molecular level to cook up the products that will make modern tires safer, more durable, and more sustainable. So, let's roll. I will spare no question in my pursuit of knowledge. Oh, these tire puns really falling flat. See what I did there?
Hi, you must be Tamara. I'm Dr. Fred Ignacy Hoover. You can call me Dr. Fred. Welcome to Eastman.
Thank you, Dr. Fred. It's great to be here. Thanks so much for meeting up with me and showing me around.
Thank you for coming, and I look forward to sharing some of the things that we do here, and hopefully we'll learn some exciting things about making tires and tire science. I have some personal protective equipment for you to wear, so you'll be safe in the lab, a lab coat and some glasses and a badge. Let's get started. Tamara and I started with seeing the different ingredients that go into a tire. So the tire is a highly engineered piece of equipment that we have in our automobiles. We see a bunch of different components, fabrics and cords that are held together by a rubber compound. The rubber compound is composed of natural rubber or synthetic elastomers and a bunch of other ingredients.
Ultimately, the idea is that all of this lasts as long as possible so that you're replacing your tires as little as possible. So just kind of take me down the line here.
Rubber ties everything together.
Yeah.
Carbon black gives us durability. Stearic acid, zinc oxide, the sulfur, Crystex sulfur, the accelerators are the chemicals that bond all the molecules together. Antidegradant provides us protection against heat, light, ozone, and oxidative degradation, and also mechanical degradation.
Very cool. So there's a lot that goes into this.
Absolutely. The best way to see what's going on is to see how this stuff gets together. So let's walk over to the mixer, and we can show you the mixing process. You mix those components together to form the rubber compound, which ties the tire together. Our rubber's mixed. Let's go sheet it out on a mill.
All right, let's go.
What we need to do is we need to get it into a shape that we can make test parts out of. Basically, what we're doing is we're making a sheet.
That's so cool. I made that.
Indeed. Tamara just rolled up her sleeves, jumped right in, and worked right beside us today.
You trust me to do this?
I do.
He trusts me, George. You could learn something from him.
There you go.
Oh,
that's it.
Cool.
We're ready to go cure them.
All right.
Do the vulcanization. Sulfur vulcanization is a chemical reaction that ties all the polymer molecules together through sulfur linkages. That converts the plastic, deformable material into the tough, elastic material that's required for the tires. Years ago, people used to use latex-treated fabrics to protect themselves from rain or in the shop. The problem is it didn't last long. After about 3 months, the rubber would degrade and it would get very sticky. Charles Goodyear was looking for a way to make an improved product, working with ways to make things less sticky. So he was combining sulfur with zinc oxide and treating the rubber with that. By mistake, he dropped a lump of rubber on his stove. When he picked that rubber up and looked at it, it was no longer soft and pliable. It was now leathery and elastic.
See, George, some of the best inventions come from mistakes. I feel like I'm making pizza now.
It won't taste as good, but it's like making pizza, right? Let's go for it. A little bit more and the light's on. So we're done. That's it. The oven doors are closed. In about 4 minutes, we'll have some pizza. What we're gonna do is we're gonna take that and do some testing. And I've got someone that you should meet.
All right, looking forward to it.
Now it's time to do some testing.
Ooh.
So there's somebody I'd like for you to meet. This is Dr. Dominica Wong.
Hi, I'm Tamara.
Nice to meet you.
Nice to meet you.
I'm going to leave you two together to talk about testing the rubber.
Thanks
it was
so
a
much,
pleasure
Dr.
to
Fred.
meet you. Enjoyed our morning together. Thank you.
Thank you, Dr. Fred. Well, Tamara, welcome to the testing facility. After the rubber is made and cured, that's really only half of the story. Here, this is where we have all the fun and we try to test the rubber to the limit. We try to stretch it, we push it, we pull it. We really try to understand where the rubber might fail.
I love the idea of using failure as a way to make things better.
Absolutely. Are you ready to get started?
Let's do it.
All right, let's have some fun.
So what is this that I'm looking at here?
So this is called the dually compression flexometer. It starts off with a rubber piece such as this one. We put the rubber piece under two metal plates and it basically presses in a sort of a series of times or repetitions for a long period of time, and then we understand how the rubber piece can deform and all the heat that kind of gets built up. We want ideally for this rubber piece
Wow, what's that? What's happening?
so this is the oscillation that we're talking about with the compression. So the metal platelets is basically pressing on to the rubber piece at very fast speeds, and it helps us understand if there is heat being generated at the rubber sample or if the rubber piece is breaking under that huge amount of abuse, essentially.
So it's great to see it in the machine, but what's the equivalent on the real road? What are the practical conditions that this is testing for?
This basically simulates a rubber piece when it's in service, when it's under rotation, if it hits a rock or it hits different surfaces, and helps us understand how the rubber responds to those different types of conditions.
Well, as much as I would love to sit here and watch it all day, I have a feeling it could take all day since you guys are very good at what you do.
Hopefully.
Could we go see something new?
Of course, you wanna go? Here we have the Instron testometer.
So what does the Instron testometer do?
A testometer basically stretches the piece of rubber until it snaps. And this is important because we want to understand the percentage of elongation before a rubber piece fails. So we have a rubber piece like this. We nickname it either the dog bone or the dumbbell. We take this rubber piece and we attach it onto the claws, and then the claws will essentially pull this rubber piece apart until you see your snap.
All right, let's see some stuff break then.
Would you like to do the honors?
Oh, can I?
Yes, you can press play right there.
All right, you count me down?
Yes, 3, 2, 1, go.
Blast off. Are they being pulled with the same amount of
Yes, they are being pulled to the same speed and to the same force as well. This way we can also compare and see how consistent these pieces
winner!
Awesome! Lastly, I showed Tamara the Gabo Dynamic Mechanical Analysis instrument, which looks at the rheological and mechanical properties of a rubber specimen as a function of time, temperature, and stress, and it helps us understand important rubber attributes such as wet traction and grip. Better wet grip performance in a tire helps with safer and better handling as well as shorter braking distances.
I love that what you do affects people every day now, but what's this gonna look like in 20 or 30 years?
I have the perfect person for you to talk to.
Let's talk first about what is going on in the future of tires, or could be.
When we think about the future tires, we see 4 kind of mega trends: sustainability, vehicle electrification, autonomous vehicles, and then ride sharing.
Autonomous cars. Everyone's talking about self-driving cars. So where do tires fit into that picture?
What we see there is putting sensors on the tire. So someone has a blowout in front of you. That sensor detects that signal, sends it back to the cloud, and gets dispersed around the vehicles, so be kind of on the watch out for a vehicle that may be out of control.
You know, it's not good for people to text and drive, but I'm kind of thinking maybe it's a good thing for my tires to text and drive. Thank you so much for giving me a little bit of a glimpse into the future.
It was great having you. Thanks so much.
You're welcome. Take care.
Thanks.
Hey, George.
Hey, Tamara, how are your travels?
Our friends at Eastman are always a lot of fun. It was a really productive day. I learned how to vulcanize.
You learned how to vulcanize? That's great, but also a little scary.
Hey.
Well, hey, did you happen to bring your passport with you to Akron?
Yeah, of course, always.
Good, because you're not coming back home. I'm sending you straight to Panama.
Wow, what's in Panama?
Well, I just got a call from Chiquita, and they invited us to check out all the latest technology they have in their shipping containers. And you know what? If it's bananas or if it's tires, it doesn't really matter. In business, you really just need to understand shipping your goods around the world.
Well, you've certainly figured out how to ship me around the world. I'm all ready to go from snow to sunblock.
All this talk of travel's given me an idea. I'm off to the ideation lab.
Bye, George.
See you tomorrow.
Traveled near and far in search of innovation. And along the way, I've gained a huge appreciation for the systems that get me around the world on time and in one piece. But it wasn't always so easy to get people and things around the world. So I am here to find out how modern technology has impacted worldwide distribution systems. My very first step, chasing down a big ship.
The view is beautiful, isn't it?
The view is gorgeous. What a perfect day to come to Panama. I'm guessing you're Andres.
Yes, nice to meet you. How are you, Tamara?
Good. George said that you are the perfect person to talk to about everything going on here. Tell me a little bit more about your background and what you do.
Well, I'm in charge of all the logistic processes from Mexico all the way to Peru. So everything related to the logistic processes in the yards, transportation, loading, unloading of the vessels.
I'd love it if you could tell me all about what's happening.
For sure. Let's have a walk into the bridge. I will explain to you a little bit about the technology of the vessel and as well all the logistic processes that we have in place in here.
Fantastic. Thank you.
Sure.
What are some of the modern advancements on this ship that make it different from ships you've used in the past?
In the past, we used these palletized vessels. We put the pallets beneath the vessel, right? But the operation was much more slower than it is right now.
So pallets are sort of the boxes that I've seen stacked up on top of one another that are like tied with the big cords, as opposed to containers, which are what we see behind me.
That is correct. In the past, we were loading pallets under deck and containers on top of the vessel. Nowadays, we have fully containerized vessels where we put the containers below deck and on top of the deck.
So the main advantage of a fully containerized vessel is speed?
So speed, of course, of the loading operations. We will go from 40 hours of operation up to 16 or 18 hours of operation. We have much more capacity on the vessels, and at the same time, we have improvements in quality.
So I would imagine that there's also energy efficiency benefits as well?
For sure. You know, in the past, on the palletized vessels, we have the control atmosphere on the hatches below deck, while nowadays, we have the control atmosphere attached to each of the containers, so we have a much more efficient process.
Speaking of below decks, I'm seeing us standing on a bunch of numbers painted here. What am I looking at? What do they mean?
These are the different bays that we have on the vessel. So 18 is one of the bays that we have, and we organize the vessel on the different bays that we have on the vessel. Not only this, but we have as well the different tonnage or amount of weight that we can put on a container that we'll put on the vessel.
You know, you might have to come home with me and help me do some refrigerator organization, because you're very, very good at this.
We'll do it.
George, if you're gonna do big industry, you've gotta be big with organization. There are are so many containers. How many containers are here?
On this vessel, we have 650 containers.
And how many boxes of bananas does each container hold?
It's 1,080 boxes per container. That's
So
it.
if I'm remembering correctly, each box is 40 pounds, so that means 28 million pounds of bananas on this boat?
That is correct, 28 million pounds of bananas.
And do all the bananas on this boat come from here, from Panama?
Actually, this vessel loads in Costa Rica, then it comes here to Puerto Almirante, and then we finish the loading in Puerto Manzanillo in Panama as well.
How many routes total do you actually have for the banana?
We have a lot of different routes. We go to the east coast of US, we go to the west coast of US, we go directly to North Europe and even to South Europe and to Asia.
Well, I'd love to see how you actually manage keeping track of all of this.
Why don't I take you to the bridge so I can explain to you a little bit more about the technology and the infrastructure that we have on this vessel.
To the bridge!
Let's go. Let me take you a little tour on the bridge.
Okay, great.
Sure. So we have all the lighting system on this part, right? If we continue in here, we have the emergency system in case of any emergency on the vessel.
Okay.
We have a telephone system in here, and one of the options, we can use it without power.
Hold the phone, literally. You're saying if I crank this, it will generate power on its own, so if there's no power, you can still use the phone?
That is correct, in case of any emergency.
I feel like I've got a pretty good overview. I mean, I think I'm ready to steer the ship.
Why not? Let's go.
I knew I liked you.
Here we have the steering of the vessel, so here we can do the autopilot or we can do the manual mode.
You were never really gonna let me steer this ship. You were gonna pretend to just put it on autopilot, weren't you?
You got it.
Oh.
And then we have the navigational chart in here, where we can see the different routes, etc., to the market.
Ah, so this replaces all those paper charts then.
That is correct.
Well, it looks like you're using a couple of different kinds of data to feed into here. I see GPS. What else are you using in here?
So we have a gyro, we have the different navigational charts, we have different technological things that enable us to get to the market in a very fast transit time.
Well, now that I've got a better understanding of how you get from place to place quickly, I would love to take a deeper dive into the container technology.
For sure, let's give you a tour. Let's go.
Okay. What's the main difference between these new containers and the ones that came before?
There are two main differences. One is the new control atmosphere unit that we have attached into the container, and then the second difference is the refrigeration unit that we have on these new containers.
Tell me a little bit more about the atmosphere.
Sure. Control atmosphere is a device that we have on these containers that enable us to put oxygen into the container and nitrogen and get out some carbon dioxide. And this will put the fruit on a sleep mode, so we will arrive on a fresh product into the market.
So what that does then is that it ensures that when the bananas get to market, they're at that perfect ripeness stage.
That is correct, totally correct. So these containers can travel up to 45 days to the different markets that we operate. And that's a huge improvement versus the previous units that we had.
What am I looking at here? I am seeing a lot of plugs.
Yes, sure. So this is where we plug the containers at the different yards that we operate. On these new containers, something very important that you should know is that we are having a reduction of around 50% on the energy consumption. We're going from 8 kilowatts per hour down to 3.2 kilowatts per hour, which is a big effort on sustainability and energy consumption.
That's a nice energy savings.
That is, at the end, what we're looking for.
I love seeing sustainability in action on a large scale. George, I know you appreciate that.
So now let me take you to the control room so I can explain how we manage all this. We have here the control room where we are monitoring everything related to the transportation, to the coordination of the yard, to the loading and unloading operation of the vessel that we operate.
All right, now what am I seeing on this screen up over here?
Here we have the control panel. This is where we are controlling the different temperatures, the different settings of all the containers that we saw at the yard. We're controlling the oxygen, the nitrogen levels.
How exactly does that happen?
Everything is via Wi-Fi. It's connected to this central system, and we're able to see the different settings.
Got it. So as they come off the ship, you put the sensor on it, and then through Wi-Fi, you get all this information constantly feeding in here. It is amazing how much granular information goes into the success of a worldwide industry. Thank you so much for teaching me about all this.
It was a great pleasure, Tamara. So at the end, when Tamara asked me to sit on top of the containers, I was shocked. This is the first time somebody asked me about that.
I just had to come up here and take in this gorgeous view one last time. You know, no matter how much I learn and see, it still always amazes me just how much it takes to get a small object we take for granted, like a banana, straight to our tabletops. Hey, George.
Hey, they shipped you back to me.
Well, not exactly, but, you know, truthfully, I wouldn't mind being shipped the way Chiquita does it. Those bananas travel first class every step of the way.
First class? Tell me more.
They travel in these climate-controlled shipping containers. They travel cool and protected, staying green for longer and longer until they hit the stores. Also, the containers now, a lot more energy efficient.
I love efficiency. Hey, speaking of efficiency, you have the new banana hook.
Yeah, I saw it when I was walking through Invention Land. You finally finished your banana invention.
Yes, it's finished. And actually, they're off to the stores now, and they should keep that gas away from the bananas so they won't turn brown as fast when you're, you know, at home. Keep it hooked up like that. So this is a brand new item.
You know, anytime you can make a product last longer, it's a win-win.
We filed the intellectual property on this. Patent should be issued any time now.
That will protect your intellectual property. And speaking of protection, I brought this little gift from Panama for you. I thought it might protect that big old brain of yours.
Hey, thank you. Nothing like a good helmet to keep you protected when you need it. You know what? I think I'm gonna actually give this off to the patent attorney. He could use a little protection from time to time.
Sounds good to me. Whatever you decide to do, I know it'll be a good idea.
Thanks, Tamara.